Right, this is a worked example for a problem which is both fitting in the modeling and also in the transformation of graphs categories. And there's a bit of crossover here, and that's particularly true in these sort of sine wave, sine function, cosine function type of problems. Let's have a look at this one. A harbour experiences a tidal change in water between 4 and 8 meters. The period of successive low tides is every 12 hours and 24 minutes. If a boat has a draft of 5 meters, what proportion of the day can it safely leave and enter? So a draft of 5 meters basically is the depth of water that's needed for this boat to sail. Now, this is part of another problem. So what it doesn't say here, but we can assume is that this is sinusoidal. With the rising and the falling of the water level is sinusoidal. So the general form of this function then, and this is a sort of the transformed function. The height function of t is a sine b into t plus c plus d, where a is a vertical stretch, d is a vertical shift, b is a horizontal stretch, and c is the horizontal shift. Now we're told, we're told that basically a is 2, because and d is 6. Mean height is 6. It tells us that implicitly there. And of course, it's 2 either side of that. So we're stretching our sine curve, which would normally go between 1 and -1, to 2 and -2. So the whole, the water, therefore, actually rises up to 8 meters and down to 4 meters. The cycle time basically is 12 hours and 24 minutes. It's 12 and 2/5 hours. So we need to perform a stretch on this t function here, on this t component here. So instead of 2 pi, our cycle time is 12 and 2/5. So we simply do that by dividing 2 pi by 12 and 2/5. And that gives us this number here, 5 pi over 31. Okay, so, and that's reflected in this function here. Height is equal to mean height plus the amplitude times the sine of the 5 pi over 31t. And if you wanted to check this, when t equals 0, then sine of 0 is going to be 0. When t is equal to 12 and 2/5, if we put that in there, we're going to get sine of 2 pi, which is 0 as well. So that is a full cycle of the sine curve. What we haven't got here is c, the horizontal shift. And this is, I think this is probably the trickiest part of this question, actually, is that actually it doesn't matter. As we go through time, I mean, we started off here at, with the tide at, with the water level at the mean height at 6. But the following day, which would actually start, here actually, then it's not going to be that, is it? And every midnight we'll see a different height, because this cycle doesn't fit into 24 hours. So it doesn't actually matter. And what we're actually looking for is the proportion of the whole of the whole time, which really is the proportion of one cycle. So, the proportion of one cycle is the same as the proportion of one day, is the same as the proportion of a week, is the proportion of 40 days, 30 or 13 hours or something like, it doesn't actually matter. What we want is the proportion of the cycle for which for which the curve is above 5 meters. Okay, so here's the curve, and here is 5 meters. So what we're wanting is this distance here divided by this distance here. Okay, yeah, that's the bit above, and this is the whole cycle. Okay, so so that's what we need there. Right, so if we evaluate at h equals 5, so we can work out what these points actually are, then we're going to subtract 6 divided by 2, and that's going to give us sine of this slot 5 pi over 31t is equal to -1/2. And then if we solve for that, then that's going to give us a primary solution minus pi by 6. And then obviously this is pi minus primary solution, pi minus pi over 6. And these two are another 2 pi. This is 2 pi more than that one, and this is 2 pi more than that one. But probably don't need those anyway. Now, the other thing is here, one is tempted, I think, to actually try and resolve therefore for t, and we would end up with, having to multiply each of these by 31 over 5 pi. But of course, since we're actually looking for the proportion, it doesn't actually matter. So we can just think of these in comparison to a cycle time of 2 pi. And that's going to give us, well, the difference between that and that is 7 pi over 6 minus pi over 6. And we want to divide that by 2 pi, which is the cycle time, the unadjusted cycle time, and that gives us 2/3. So the answer is that this boat can enter and leave the harbour 2/3 of the day. The other third, of course, there isn't enough water for it to move around. So that is it, really. So I think that kind of illustrates one or two very interesting things. I mean, first of all, we obviously recognize it's a sine curve. There are lots of these modeling stroke transformation of graphs, Ferris wheels rising and falling and all sorts of things. But we can, if we look at the data, we can form we can populate this. But I say this one's got a little bit of a twist, as to this aspect of it, what proportion of the day is a kind of a bit of an odd bit of wording. But anyway, we've unpicked that one. We've worked it through and realized that we don't actually need to adjust for this, because effectively we're going to, when we're looking at this ratio, this factor is going to appear in the numerator and the denominator, so it's going to cancel out anyway. So we've got an answer of 2/3. So that's it. Thanks for listening.